if we have a function that is one-to-one, that passes that horizontal line test, there's a process to find an inverse. And I'll demonstrate that with you now. First thing we're going to do, and I'll leave the instructions up here while I work through number 1 with you, replace the function notation with y. So instead of f of x, we're going to write y. The second step says switch the x and the y. Now remember that an inverse function takes the output to the input of the original function. So it switches the roles of x and y. And that's exactly what we're going to do to find the inverse. We switch x and y in our original function, and now we're going to take this new function and solve for y. So x equals 4y plus 3. I'm going to get y by itself here, so I'm going to highlight y. I need y by itself. Subtract 3, x minus 3 equals 4y. I need y by itself, divide by 4. We end up with y equals x minus 3 over 4. And then the last step, rewrite using function notation. So the y is now going to become f of x. And this means that my function 4x minus 3 here has an inverse function of x minus 3 divided by 4. Things to point out, notice in my original function f, the input gets multiplied by 4 and then added to 3. In my inverse function, we subtract 3 from the input and then divide by 4. So we're doing the opposite operations in the reverse order. And that's how an inverse function undoes what the original function did to our input. Now, how do I know this function is one-to-one? How do I know I can just do this with the function? Well, 4x minus 3 is a linear function. It's a positive slope of 4, so it's going to be a straight line with a tilt to it, an incline, a slope. So any vertical line that I draw is only going to hit that line in one place. Looking at number 2, to determine if it's one-to-one, we could graph. Graphing is usually a good way to tell, and then we can determine from that horizontal line test. I have a cube root here. If you remember how cube roots go, they kind of go like that. The plus 2 here on the inside means it got shifted to the left by 2, if you recall those transformations that we did before. The multiplier of 5 in the front changes the spread. It compresses or stretches the function when we multiply by a number in the front. So that's all that's happened here. It'll still pass that horizontal line test if we graph it. So let's work through number 2 together. First, change the f of x to y. Switch the x and the y variables. And now we need to solve this new equation for y. So we'll start out by dividing by 5. I'm going to make this a new line. We'll divide by 5. Notice I'm solving a radical expression. So I need to get the radical by itself. I do. I can cube both sides. So x over 5 cubed equals y plus 2. And then to get y by itself, I would subtract 2. X over 5 cubed minus 2 equals y. We might clean this up a little bit since division and exponents actually do play nicely together. 5 cubed is 125. Minus 2 will give us y. And then we can write it in the inverse function notation. F inverse equals x cubed divided by 125 minus 2. Try number 3 on your own. Pause the video, and when you resume, I'll work through it with you. First, change the f notation to y. Switch the x and the y. And now I need to get y by itself. Add 4. This one's a little strange because it is a y on the bottom, but we can multiply both sides by y. But I'm not going to multiply it out. I don't want to do that. Because I want the y by itself, I can divide by that x plus 4 to get the y by itself. So y equals 2 over x plus 4. And that's going to be my inverse function, 2 over x plus 4. And then one last one, number 4. Try this one on your own, pause that video, and when you resume, we'll walk through it. Change the function notation to a y, swap the x and the y. we got to get y by itself, so I could multiply by y by itself divide by x, and we get y equals 1 over x. What makes this one really interesting is this function is its own inverse. And if you think about it, that makes sense. F of 2 is 1/2. F inverse of 1/2, 1 over 1/2, or 1 divided by 1/2, 1 copy dot flip, I get back 2 again. This right here is even an example of a composition in that I started with 2. F of 2 is 1/2. I plug the 1/2 into the next function, and I got a new answer. But because these functions are inverses, the new answer matches what I started with.